So, good morning, everyone. In today's lecture, we are going to start with introduction to uh, triple integral. But in triple integral, we need a lot of knowledge, which related to three-dimensional geometry. So, first of all, we'll just talk about the three-dimensional geometry for a while. And once we are done understanding all the geometric figures in three-dimensional space, and then later we will actually start with the triple integration. So at the start, we will see from the two-dimensional point of view, and in two-dimensional point of view, just like we studied earlier, that when I want to name a certain point in two-dimensional space, I can name it according to Cartesian coordinate system. I can name it according to the polar coordinate system. So every point will be named as x comma y, where x is the distance from y-axis and y is the distance from x-axis. So when I am naming a certain point, in Cartesian it is given in this form. In polar coordinate system, the idea is we take the distance from the origin and we look at the angle theta with positive direction of x-axis. There is one more. To convert Cartesian coordinate system to polar coordinate system, what we actually do is we put x is equal to r cos theta and y is equal to r sin theta. When the polar coordinate system is convenient, so whenever we have equations like lemniscate, cardioid, circle, so these kind of structures are better dealt with polar coordinate system. In Cartesian, the integration may become difficult if you go directly solving it by Cartesian. Whereas in polar coordinate system, the things become very easy. Uh, one more thing is the one more coordinate system. So it is not formally. So x is equal to a r cos theta, y is equal to b r sin theta. Anyone who can identify this? That is, when you have equation of the form x square upon a square plus y square upon b square equal to 1. What is this? X square
Ellipse.
upon ellipse. So when you're talking about a coordinate system, we actually identify each and every point according to with respect to something. In the polar coordinate system, if you see x equal to r cos theta, y is equal to r sin theta, this is defined by a circle. Okay, so you are naming each and every point in the plane with respect to a circle of radius r and angle theta. Okay, in the similar manner, this is elliptical coordinate system. Okay, in two dimension, of course, there is a elliptical coordinate system in three dimension also. So this coordinate system can also be used. Okay, and dx dy in this case is going to be a b r dr d theta. Okay, this we didn't actually solve in two-dimensional system, but this is some extra knowledge that you can keep. So our aim is actually to solve the integration, no matter what the coordinate system is. Okay. So in order to solve some integration, if I want to substitute x is equal to ar cos theta, y is equal to br sin theta, in that case dx dy will be replaced by abr dr d theta. Okay, so this complete setup is, I mean, uh, similar to what we are going to do in three-dimensional space. So before I actually started, I just want to know what is x plus y plus z is equal to 1. First of all, what is three-dimensional space? Space with three axes, x, y, and z. So that is a three-dimensional space. The number of axes is actually something that defines dimension of a space. I say two-dimensional space, it means that x-axis and y-axis are there. One-dimensional thing is simply one variable x, the real line. Three-dimensional space is having three axes. So if I talk of four-dimensional space, it means that there will be four axes. Of course, you cannot imagine that, but it will consist of four axes. Now, in the three-dimensional space, my question is, what figure will this represent, this equation? Anyone?
A line.
Plane.
Who said plane represents a?
Sir, me, Abhishek.
Okay. So, represents a plane. Very good. Now, this is something that you have seen in your 12th standard. The equation, I request that you write this down because I don't think these are going to be in the notes also. This is extra something that I'm teaching today. So ax plus by plus cz plus d equal to 0. This represents a plane. Represents a plane. This is the general equation of plane. You have seen this in your 12th standard. Ax plus by plus cz plus d equal to 0. This represents a plane in three-dimensional geometry. Now, my next question. So I will rub this above part here. And my next question is, what is x plus y equal to 1?
Line.
X plus y equal to 1 is a
Line.
line. Okay. Anything else?
Intercept on both axes is 1.
Okay.
Inclined at 120 degree with x-axis.
Okay. So I will make two sections in this. One is in two dimensions. What happens in 2D and what happens in 3D. Now, whatever you are saying, inclination, intercept, line, is in two-dimensional space, it is line. Can anyone tell me what is x plus y equal to 1 in three-dimensional space?
XY plane.
XY plane, sure.
Sir, in 3D, z is equal to 0 in this.
What is 0?
Z 0. Coordinate of z is 0.
Okay,
So it is also represent a plane.
okay. Wait a minute. So the equation is x plus y equal to 1. What do you see? What is this?
Plane parallel to y-axis. Sorry, z-axis.
Okay. So x plus y is representing a plane. But now what I will do is I will look it from the top. So you can see that this is a two-dimension thing. Now there are just two axes, x-axis and y-axis. I just want to make clear here that x-axis is red and y-axis is green. So if we look from the top, I'll just change the color of this in order to make it visible properly. I'll make it black. Green. So what do you see now? So this is a two-dimensional space when I'm just looking at the xy plane. On xy plane, it is a line. The z is absent. So what happened to the z? So you have got a plane. So this is how you should generalize. I mean, in this equation, now let's come back to our screen. Ax plus by plus cz plus d. We know that this complete equation represents a plane. And if I want to look at x plus y equal to 1 here, so if you see the value of a is 1, b is 1, c is equal to 0, and d equal to minus 1. So this equation you can get from this by just substituting some values. Okay, so a, b, c, and d, if you substitute, you are going to get this equation. So in general, any equation will represent a plane in 3 dimensions. First and very important remark, you take any equation, linear equation, and that will represent a plane. Now my next thing which I want to point out here is, so we started with the equation x plus y equal to 1, and this is going to be in general true. Okay, x plus y equal to 1. I'm talking in 3 dimensional space, it is a plane. Let me just write it down here. Okay, so if I want to draw the graph of this in 3 dimensional space, as we are going to need it to draw in each and every example whenever I want to integrate. So what we are going to do is we'll see what happens on xy plane. So if I want to draw this equation on xy plane, what is it is going to be? It will be a straight line like this. This is x plus y equal to 1. Now the z variable is absent. Okay, so the transformation of this, I'm drawing it here. So this is x-axis, y-axis, and this is z. On xy, we have seen that it is a straight line like this. Now, I'll take one point here. What will be the coordinate for this? Anyone? What are going to be the coordinates?
1 comma 0.
1 comma 0, exactly. In 3 dimensional space, as there are x, y, and z axis, so what it is going to be?
1 comma 0 0.
1 comma 0 comma 0. Now what I'm going to do, I'm going to go 1 unit upwards from this. Upwards. What are going to be the coordinates here?
1 comma 0 comma 1.
1 comma 0 comma 1. Does this point satisfy this equation? Is x plus y equal to 1 for this point too?
Yes.
Yes. If you go 100 units upwards, still that equation will be satisfied. So if you go 100 units upwards,
Yes.
so that is going to be 1, 0, 100. Even this point satisfies this equation?
Yes,
Yes,
sir.
sir.
Yes. So if z variable is absent, what happens is जो भी 2 dimension का graph है वो extend होगा along z axis. That is the idea. So if I want to draw any graph, say for an example x plus y equal to 1, what I'm going to do, I will draw its graph on 2-dimensional space. Z absent है तो Z axis के along उसको extend करो. So I will go back again to the graph that we have here. So you can see. So we have got that line x plus y equal to 1. As the Z variable is absent, तो तुम्हारा plane extend हुआ along Z axis. I hope the point is very much clear now. Okay.
Yes, sir.
Yes. So now I will give you a short exercise. Say you draw y equal to x square. What is this going to be, anyone? Y equal to x square. In 2-dimension it is? What is it in 2-dimensional space?
Parabola.
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 What will be in 3-dimension? Can you draw it? What will happen? You can simply say what is going to happen if you draw the graph of it.
So it will be a parabola, but again, it will extend in both directions, right? Upward and downward.
Yes, exactly. So y equal to x square. So I'll just erase the previous graph. So you can see it here now. So if you see from the top x and y axis, so what do you have is a parabola. Z variable is absent, so the parabola is extended. You can see this on the graph. Okay, so the parabola is extended in upward and downward direction. So जो भी variable absent होगा, parallel to that, you will have to extend it along that axis. So this is the common idea. So you can draw any of the graph like this now. Say y equal to x square I have drawn, so I will make it x equal to y square. So
Sir,
yes,
so it's extended from upward and downward just to give a idea to the viewers, right? It's not.
no. In 3-dimensional space, the graph is like that. It's not just to give the idea. So if you try to draw the graph of this y equal to x square, the graph is like this. This is actually I'm drawing the graphs here. It is not something that I'm actually giving the idea. In 3-dimensional space, things work like this. What you have studied for y equal to x square was for xy plane. But now where I'm working in 3-dimensional space. जैसे कि तुमने 12th standard में the equation of line that you were doing, equation of line in your 10th standard that you know, ax plus by equal to c, ये एक line होती है, ये 10th standard में हमने पढ़ा है. But in your 12th standard, one of the equation was x minus x1 upon a, y minus y1 upon b, z minus z1 upon c equal to KSA, or let's not write anything there. And you call this symmetric form. Why क्या जरूरत पड़ी ये simple equation छोड़ के इतने complicated में जाने की? The reason is this in 3-dimensional represents a plane. तो चीजें 3 dimension में अलग होती है. And we need another equation. And that's why this equation of line is in 3-dimensional space. मतलब एक्स वाई जेड एक्सिस अगर आ जाते हैं तो लाइन ऐसी दिखेगी. It won't look like this. This is a plane in 3-dimensional space. Am I clear? Yes or no?
Yes, sir.
Yes, sir.
Okay. So I hope you have understood now. So equation of parabola is when you draw the graph in three-dimensional space, how you draw it. If some variable is absent, you just extend it along that variable. So what I was showing is if you make the things like this, so you can see the graphs here. Say before drawing this graph, I'll let you think on this. What will happen for this now? Say if I have uh, z is equal to y square.
सर एक्स एक्सिस से एक्सटेंड करेगा सर कर्व.
So this will extend along x-axis, but on yz plane it is a parabola.
Parabola, yes.
So z equal to y square. I'll just change the color for this. So you can see, I'll delete the previous one. So you can see on yz plane we have actually drawn the parabola, and then it has extended over the x-axis. Look, when you see it like this from x-axis point of view, so you get a parabola, and as the x is absent, so we have extended it along the x-axis. Fine, clear up to this. Now we'll go ahead, we'll rub this part. X square plus y square equal to 1. There's three things I want to discuss. So first one, anyone, what is it?
Equation of circle of radius 1.
Okay. Anything else?
In 3D, it will be a hollow cylinder.
Yes,
There are
Abhishek.
cylinder.
In 3D, it will be a hollow cylinder.
Okay. Yes,
Yes, the same answer. Cylinder.
same answer for the first one. Very good. So that is exactly right. So in two-dimensional dimension, if you see, of course, it is a circle. But in three-dimensional space, in 3D, this is a cylinder. Along. So let me just tell you that there are some terminologies for a cylinder. So when I say cylinder, so it is along some axis. You have a single axis along which this cylinder is there. Okay. So in this case, the first one, the cylinder is along
Z-axis.
z axis. Then similar kind of equations can be made. Say y square plus z square equal to 1. This is also cylinder along x-axis. And x square z square equal to 1. This will be cylinder along
Y-axis.
y. So whichever variable is absent along that, it is going to be the cylinder. So we can make a remark over here. So if you want, you can write down the first one for the plane we have written. Now second remark we can actually write down here is that x square plus y square equal to a square represents cylinder. represents the cylinder. Now let's talk about the next one. Now here all three variables are present. Can you tell me something? So you actually have an idea of curve tracing. Let's see if you can derive some observations and think of the graph. I can actually draw the graph immediately, but I don't want to do that because this is the vast topic and you need to understand it properly.
It will be again circular, cylindrical only, but it will now spread because it is now along the x and y axis also.
Now, what will happen? Can you repeat it?
It will again be a form of cylinder only, but in this it will now spread along the x and y axis. So it will
Okay.
be somewhat away from the z axis, maybe.
Sir, it will be along z-axis conical shape.
So it will
Sir, it will form cone.
increase in height from
Yes,
z-axis.
sir.
Okay, what is Abhishek? Abhishek, what are you saying?
It will be symmetric around XY plane.
Kunal?
Sir, from the point of I'm assuming from the point of origin, it will increase in height in z-axis, and
Okay.
it will be in sort of a. I think it will be in a conical shape.
Yes, it will be
Yes, sir.
Okay, we will see now.
Along z-axis.
because
देखो जब
it is a square.
exactly. Wait, you're somewhere around the graph. You have got an idea. Of course, you're thinking on it. So I'll give you one more aspect how you can think over it. So XY plane मतलब Z की वैल्यू क्या होती है? On XY plane, what is the value of Z?
0.
0.
So if Z is equal to 0, I will see on each plane. I mean Z equal to 0 plane के ऊपर क्या हो रहा है? On Z is equal to 0 plane, what do you get? X square plus Y square equal to 0, which means that what you are going to get, which points satisfy this equation?
Origin.
Only origin. So 0 0 0. तो z equal to 0 plane जो है उसके ऊपर एक ही point है origin. That's it. What will happen if z equal to 1? तो look, मैं ग्राफ यहीं पे निकाल रहा हूँ. Try to understand this. अब z equal to 0 पे इकलौता एक point है. z equal to 1 पे क्या आ गया है? एक सर्कल आ गया है, right? What will happen if z equal to 2? Say 4. So you'll get x square plus y square equal to 4 square. So then you will get a bigger circle, right?
Yes, sir.
If you go some bit more value of z, if you take larger value of z, you will get a larger circle and will join.
Sir, it will be like parabolic.
Sir,
But
it will be a upwards cone.
Yes.
It will be a cone along
Yes.
z-axis.
So it looks like a cone, but the structure can be like this also. A parabola rotated, right?
Yes, sir.
So how can we identify which one is my curve? This one, the second one, or the first one? Can you?
Sir, first one,
Why?
because sir, it is continuously increasing.
In the second one also it
Sir,
is increasing.
No,
radius
sir,
in the second one, sir, radius is not increasing.
No.
In first one,
It is also increasing. So I haven't drawn the graph properly. Say, I'll take a parabola and I will rotate it. So in
So we
parabola,
can say in second.
so If you draw a parabola like this, so as the value of z will increase, the circle will go on increasing. So you can see that it is increasing. I need you to look at a bigger picture here so that you can identify which of the graph is correct for the second one.
So second one will be correct.
Why?
So because radius is increasing in the terms of square, and in
Uh,
first one it is linearly increasing.
but it is increasing, right?
Yes, sir.
In both of the cases, it is increasing.
Yes,
So
sir,
you
it is.
put any value of z and still you are getting a circle there.
Both are correct.
Paramveer, you want to say something?
No, sir.
Okay, I will give you a hint. What happens on, say, YZ plane? Think of YZ plane and see the structure that you will get on YZ plane.
Not getting, sir.
Y is equal to plus or minus z will get.
So what is it? Y is equal to plus minus z. Abhishek.
Sir, it represents a line in YZ plane.
So which graph is correct now?
So the
The
first one.
first one.
First one.
First one, exactly. So look, on xy plane in both the cases, if you see it is, if you go on increasing the value of z, in both the cases you are going to get the circle. But what characterizes our graph is, now I am looking at yz plane. On yz plane, I'll write it down here. On yz plane, we know that on yz plane x is 0. So what we get is y square equal to z square, which means that y equal to plus minus z. Okay, matlab this is a straight line. So if you look at this graph and in this yz plane, you are getting a straight line like this. Whereas in this, if you look at yz plane, you are getting a parabola. I hope things are clear now. So now I will go for the second one. What is this? Next one, y square plus x square plus y square equal to z. What is this? Even at z equal to 0, you will have a single point 0, 0, 0. As you can see, if you put z equal to 1, what you are going to get? A circle of radius 1. And say z equal to 4, so you will get circle of radius 2. Right? So now what is this? Anyone?
So the parabolic one that is drawn here.
Yes. So now on this, what I can observe is, if you look at yz plane, put x equal to 0, what do you get is y square equal to z. This is x-axis, y-axis, and this is z-axis. And I'm looking at x equal to 0, which means that yz plane. Or yz plane पे क्या है? It is a parabola that is opening towards z-axis.
Z axis.
So, so this structure is called the paraboloid. Paraboloid, and this structure is cone. Okay. So let's see this on the actual graph we'll draw the actual graph of this. And so x square plus y square equal to z square. So we can see this. So what we have got is a cone. All the structures are actually satisfied. So if you look from the x-axis point of view, so you get two straight lines, x equal to plus minus z and that kind of thing, the observations that we make. The other equation, x square plus y square equal to z. So let me change the color for this. So you can see now you have got the paraboloid. So this is how things change. So we need to really be observant about this. Fine. Who can try this now? Say x square plus z square equal to y square.
Cone along y-axis.
Cone along
Y-axis.
Cone along y-axis.
cone along y-axis. So if we change the variables now, you can actually identify the things. So the last one, x square, say y square plus z square is equal to x.
Sir, previous rights.
Paraboloid along x-axis.
Paraboloid along
Yes, sir.
x-axis.
X-axis.
So the right hand side variable represents along which axis the graph is going to be. Okay. So there are some examples if you go for theory questions actually where you need to find the integration over intersection of two paraboloids, and in those cases what we actually need to do is we need to identify the regions and you should be able to do the graph. Now as we have made everything clear, so now I would like to introduce you to some of the coordinate systems that we are going to work with. The first one is spherical. Cartesian you already know, so I won't write it down. Spherical coordinate. So I told you the idea is when you're talking about a coordinate system, uh, we name each and every point in the space with respect to something. Okay, in polar coordinate system, you are naming with respect to a circle. I mean, r cos theta, r sin theta represents a circle. So you are approximating a point with a circle. In the spherical coordinate system, the same thing we are going to do. So if I want to convert something to a spherical coordinate system, what we'll put is x is equal to r cos phi, y is equal to r sin phi, sin theta, z is equal to r cos of theta. So this is the substitution. If I want to convert a Cartesian system to a spherical coordinate system, these are the substitutions that we'll make. Just understand what is r. What is r, anyone?
Radius of sphere.
Radius, of course. Uh, if I have a point in three-dimensional space, look, of course, I'm using the word sphere again and again, but what we are trying to do here is I'm trying to name each and every point in the space with in terms of r, theta, and phi. Okay, so what is r? What is the significance of r? What does it represent? If this is the point P whose coordinates are x, y, z with respect to the Cartesian coordinate system, now I'm naming this point in spherical coordinate system as r, phi, and theta. So what will this r represent? That is my question.
Distance from origin.
It is the distance from the origin. So whatever distance it is going to be there, is distance from origin. Distance from origin. This is the significance of r. Is phi. This you actually have to concentrate. So there are different ways to give the significance of phi, but what I will give is to make it relatable to polar. That's why I'm going to write this. So angle with positive x-axis, positive x-axis for the projection of point on xy plane. So what I'm saying is, you put this down wherever the point is. I will put this down on the ground. So there you will get a point, and for that we actually know how to find the angle with positive x-axis. So this is phi. So you drop that point on the ground and then you see what angle it makes with positive x-axis, and that is phi. If you have difficulty understanding this, please ask right now, or I'll talk about theta. Theta is the most complicated actually. This is angle with positive z-axis. Angle with positive z-axis. Now for this again I will go to the graph. I'll delete the previous ones. I'll draw a sphere, say x square plus y square z square equal to 4. So we have a sphere. If I take a point, any point on the sphere, how can you calculate its angle with positive z-axis? Let me just clear that the z-axis is colored blue, dark blue. When you take a point anywhere on the sphere, so what we are going to do is we will need its angle with positive z-axis. How you are going to do that? What range it will have? कितना angle हो सकता है maximum for any point
0
on
to
this?
90.
Sir,
90?
maximum 90 degrees.
Sir, 0 to 90.
Are you sure? If I take a point in the lower half of the sphere,
So minus pi to
Sir,
plus pi.
180.
180.
180.
180.
So from the diagram you can see that तो theta की range क्या होगी always? It is going to be 0 to 90. So if you take any point at the lower end also, at the south pole, that I would like to name it. At the south pole too, if you see with positive z axis, it will make maximum angle is 180. If the point is on the z axis, which is 2, positive 2, the angle is 0. It won't go beyond this. Am I clear? So I hope you are convinced that your angle will not cross 180, even if it is on this side, say the negative y-axis. If you see on the negative, the y-axis is green. On the negative y-axis, if I take this point, this one, for that your angle is going to be 90. Fine. So I'll write it down. Ranges. So R is going to take the range from 0 to infinity. 0 is less than or equal to R is less than infinity. Phi can take what values?
0 to 180.
No. What is phi? Phi is angle on xy plane.
So 90 degree.
Abhishek, Sumed,
Sir, 0 to 360 degrees.
0 to 2 pi. So phi can take values from 0 to 2 pi. Strictly less than 2 pi. And are equal to no problem. For the z-axis, the theta is from 0 to pi. Okay. Then there is another coordinate system, which is cylindrical coordinate system.
So previous.
Sir, I had a doubt.
Yes.
Hello.
Yeah, just a minute. Cylindrical coordinates. I'll go to the previous slide. Someone will have. Yes, ask your doubt.
Sir, in that theta is angle with positive z-axis only.
Yes.
Or it can be with negative also.
No, only positive z.
Sir, can you explain it again?
So I showed the graph already.
Sir, it goes to negative also, right?
Point can go to negative,
Okay.
but
Yes.
angle is with positive z axis.
Yes, sir.
So if I want to convert, so I want to name each and every point with respect to some cylinder. What we are going to put is x is equal to rho cos phi, y is equal to rho sin phi, and z is equal to z. So the significance and everything for this is nearly equal to the polar. Okay, but in this case, rho represents the distance from z-axis. Distance from z-axis. Look, actually, we are calling it coordinate system, but these are kind of substitutions that we use to solve integrals. Okay, so substitutions can be manipulated. In some example, I can put x is equal to rho cos phi and z is equal to rho sin phi, y is equal to y. But I'm not going to go into the details of this. Once you are very much comfortable with these things, you'll be able to do it on your own. Okay, so for now, what is rho? Rho is distance from z-axis. What will be phi? Angle with positive x-axis on xy plane. This is very important point. and z is used as it is. The coordinate system, and the last is elliptical coordinate. So x is equal to a r cos phi, y is equal to b r sin phi, sin theta, z is equal to c r cos theta. Significances are same, so this is what you can see, that nearly equal to spherical. Just the components along x-axis, y-axis and z-axis are given to you. Okay, so these are the three coordinate systems that we are going to use later when we will be solving integration, triple integration. If you have any doubt, please ask.